Okay, if we look at one of the specification statements, it says all students should be able to describe experiments to investigate the motion of everyday objects, such as toy cars or tennis balls. Okay, so let's have a look at the first thing. I mean, how would we actually go about measuring the speed of a toy car? So I'm going to talk about some of the things that they would be looking for if you're trying to answer that. You will need to think about the equipment you're going to use and also the measurements you're going to take and also the method you're going to be using. Let's think of a simple way. Well, this is our toy car. I'm just going to keep it very simple. And what we have to do is we have to measure two things. We know that the formula for measuring speed is distance divided by time. So there are two things we need. We need the time, and we need the distance, and we need the time. Perhaps we could set a particular distance. So we just have a particular distance that we're going to set the car to travel, and we measure the time it takes to cover that particular distance. So in my setup here with my toy car, we could have, for example, a distance measured out on the floor of 1 meter, and we then time. So stopwatch. We need a stopwatch to time how long it takes to cover this particular distance. Now, if this starting point here, if we wound the car up, for example, or it's an electric car and it's just starting at this position, obviously it needs to pick up speed. So the first bit of its journey is actually it's accelerating, and then perhaps it travels at constant speed after that. So if you want to know actually what speed it's going when it's traveling at a constant speed, perhaps we need to set the car off running for the first bit of the journey, and then actually time it a little bit time later over 1 meter. So this is where the car passes this start position, okay, and when the car passes the end position. So basically this bit of the journey is where the car is accelerating and then reaches a constant speed. So actually between this position, the start here, and here, we are actually measuring a constant speed. Now there is a problem with using a stopwatch. Whenever somebody is using a stopwatch, we have a reaction time problem with the operator, because your reaction time, when you see this car pass this certain point, okay, your reaction time is around about 0.2 of a second. Okay, and this is an error that you introduce into your measurement. Now, how do we avoid an error in our taking our reading of time? Okay, one thing we could do is to use what we call light gates to measure the time more accurately. Okay, so I've shown a sketch diagram here of some light gates. So what they do is you have on this side you have a light that shines across, and then on the other side you have a detector which detects the light. And what happens is if you fit a piece of card on top of your car, when it passes through the light gate, it blocks the light, and basically the detector then doesn't detect any light, okay, and it switches on the timer. And then when the trolley gets to the second light gate, again it cuts the light off, okay, and then the timer stops. So let me say that again. When this piece of card goes into this beam, it starts the timer, and when it goes through this beam, it stops the timer. And if we set these 1 meter apart, then essentially we're timing very accurately the time it takes the trolley to go between the 2 points. And a setup like this, the light gates can have a sensitivity of it can be up to hundredths or thousandths of a second. Now, actually, what we've been talking about in the examples that we've been above, with the light gates and the other ones, is we're actually timing the time it takes to cover 1 meter, and getting basically an average speed for that for the car doing that distance. It could be that the speed of the car is actually changing a bit, okay, between the start and the finish. So how do we know? If you want to know the detailed way that the speed changes as the car moves along, how can we do that? Well, what we could do is we could have a distance measuring instrument, such as a meter rule, and we video the car as it travels down the length of the meter rule. So we'd set up our video. We would run the car with maybe a marker on the top, so a piece of card on the top, and would video it. And then we can analyze the video, because the video, it might be recording the frames. That means the time between different pictures that it takes might be about a hundredth of a second. So every hundredth of a second, we will have a picture of the car against the background. So we'll be able to see the distance the vehicle travels every hundredth of a second as it travels the length down the meter rule. Okay, and so we will be able to tell distance travelled divided by a hundredth of a second. We'll be able to tell the speed at different points in the journey.